Alright, this video is 5.2 and we're going to be analyzing discrete random variables. Alright, so consider the discrete random variable where x is equal to the APGAR score of a randomly selected baby 1 minute after birth. Now, APGAR is a test they do for their reflexes just to make sure the baby's healthy. So the APGAR score ranges from 0 to 10. And what you see down here below each discrete value is the probability that they get a 1 or a 2 or a 3 or 4, whatever it is. All right. Now we can display the probability distribution in a histogram. Values of the variable go on the horizontal axis. You can see the APGAR scores are right here. And the probabilities go on the vertical axis. Okay, so I look at our probabilities. Remember, they're all less than 1, so it's listed as a decimal. And it only goes to 0.5 because if you look at the table, the highest value that you see is actually a 0.3. So really, it doesn't even have to go higher than that, but it does just for just the graph looks good. There is one bar in the histogram for each value of x. So there's a bar for 0, 1, 2, 3, 4, 5. Okay, all the values of the test that can come out. And then the height of the probability is, or height of each bar gives the probability of that corresponding value. So if I look at the probability of getting a 9 is like 4 point something if I look at the graph, and if I look at the table, sure enough, it's 4.37. So we did histograms a while back. I've just shown you this is where they come back. Okay, probabilities go down on the vertical axis and the values go on the horizontal. Now the mean, or what we call the expected value of a discrete random variable, is an average of the possible outcomes. Okay, that's important that you catch that. It's an average of the possible outcomes, all right? But a weighted average in which each outcome is weighed by its probability. So there's a lot of words here and a lot of symbols, and I don't want to mess you up. But look, here's the table we just saw. With like an APGAR score 0, the probability of getting a 0 is P1. All right, probability of getting, or value of getting a 1, here's the probability of getting a 1. Test score of a 2, here's the probability of getting a 2, on and on and on. So the way that we find the mean is we multiply, all right? So all this symbol means is we multiply and we add. So we multiply down x times p1, that's this part right here, plus then we do this, these two multiplied, here it is, plus this one, these two multiplied, and we do it till we've done every value in the table. All right, now don't worry too much about this because I'm going to show you how the calculator does it for us. But that's how we do it. We multiply, then add, then multiply, then add. Now, with the mean as our measure of center, hopefully you remember that. Mean is our measure of center. Okay. It shouldn't surprise you that we use standard deviation as a measure of spread. Okay, this goes way back to chapter 1. Mean is our measure of center, standard deviation is our measure of spread. So the standard deviation of a discrete random variable measures how much the values of a variable typically differ from the mean. This is a key phrase that you will use when you interpret. Suppose that x is a discrete random variable with this distribution and that mu of x is the mean. The way we calculate the standard deviation is we take that first value right here, we subtract the mean that we calculated, and we square it. We multiply that then by the probability, and then we do that for each value in the table. Again, I'm going to show you how to do this in the calculator, so don't stress. Now, let's look at an example. El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units, 18 hours, basically. The tuition charge for a student is $50 per unit. Suppose we choose a full-time community college student at random. The probability distribution of the random variable tuition charge for the chosen student is shown here. Make a histogram of the probability distribution and describe its shape. Okay, yes, you're going to have to do this. But look, tuition are our discrete variables, okay? There's the dollar amounts and then the probability that they pay that tuition. That is the probability part. Now, whatever's in the top row goes on the horizontal axis. Whatever's on the bottom goes on the vertical, and it's probability, so leave them as decimals, okay? And you do bars for each value here gets a bar in the histogram, all right? So the problem says make a histogram, which I've shown you how to do, and then describe its shape. All right, so this is not symmetric, this is not skewed. All you really can say is it's fairly symmetric with 3 peaks, and list where those peaks are at $600, $750, $900. You could describe a graph if it followed suit of a symmetric or right skewed or left skewed, and you would want to tell me where the peak is, which one is the highest or the most frequently used value. All right, number 2 says calculate and interpret the expected value or the mean of T, which is the tuition of an El Dorado College student. So we're going to find the mean. Now, pause the video and write down these steps right here. Write down these steps, and then I'm going to show you how it looks in the calculator. All right, in the calculator, what you're going to do is put like the top row here, the tuition charge in list 1, and in list 2, you're going to put the corresponding probabilities. Once that's done, if you look at your keystrokes, you're going to go to Stat, over to Calc, want one variable statistics, and then for list, you want it to be L1, and then this is new. You're going to do frequency list, and you want it to say L2, so you hit second and 2. All right, then you just come down to calculate and hit enter. And what it's going to spit out for you is X bar, that's your mean, and sigma down here is your standard deviation. So make sure you pay attention to those two things, all right? X bar is the mean and sigma is standard deviation. We'll need that on the next slide. But right now the X bar comes out to $732.50. If we had done it by hand, we would find by doing 600 times 0.25, 650 times 0.1, so on and so forth, we would get the same value. I want you to use a calculator. It's just simpler. Now, you have to interpret though. Be careful that you don't just stop with the number, but you also interpret. So the way that you would interpret any expected value has to have context, but it would phrase like this. If many, many students from El Dorado Community College are randomly selected, their average tuition charge will be about $732.50. Okay, so you can see you're going to have to change the wording up per problem, but it always has to start with many, many students, many, many people, whatever. Then the average whatever will be about whatever you get for expected value, right? Now, example 3 has us finding standard deviation, all right? So you're going to use the calculator again, pause the video and write down the steps, and it's going to be very similar like what we just did, but this time we're looking for the sigma value on the output screen. So if I pull up my screen again, here's my output screen, and sigma is down here. It's that little circle right there, and it's 102.80. This is dollars and cents, so you'd round to 2 decimals. So that's my standard deviation. Now, interpreting standard deviation is important. You have to be able to do that in context. To interpret standard deviation, you have to use this phrase right here, that typically varies from the mean. This phrase is going to be true to every time you interpret a standard deviation. Now, obviously, you wrap it in context. Randomly selected student from El Dorado Community Colleges has a tuition, typically varies from the mean, and here's the mean value that we found by, and then there's your standard deviation. Okay, so there's not a lot of work to show me if you're using the calculator. However, if you don't have the interpretation sentence, you don't get credit. So make sure you don't be lazy and you use the correct wording and correct context in your sentence.